Right, good day and welcome back again to Everything Mathematics. And today we're continuing again with our trigonometry. And we're going to be looking at a part one of two, looking at one of the rules with trig, which is the sine rule. Note, we use the sine rule. Am I jumping the gun here? Let's get into the video. So our objective for today, of course, is to learn when the sine rule is applicable. In other words, when can we use it? When can it be used? And our focus today, part one, will be finding the missing side of a triangle using sine rule. So that's part one. Tomorrow, God's willing, we're going to look at part two, where we'll be finding the missing angle. So I'll try again not to mix them up. Let's just do one at a time. In that way, hopefully, you'll pick it up better. Hopefully. Good. Conditions. When it comes to using the sine rule, basically, you need to know the condition. There is basically a condition that must exist. Or maybe I should say more than one, but mainly this. So if you're given two sides of a triangle, so if two sides of a triangle is given and an angle facing those sides are given to, then the sine rule can be used. And this kind of complicates it a little. If I show you, it might be a lot easier. In fact, no. I have an image on the next slide that will show you perfectly. So this is basically the sine rule in a nutshell. So for sine rule to work, here you must have one side, an angle here, and a representation of an angle here. So this angle goes with this side, and this angle will go to this side. Notice though only one would be missing. Good. Of course, you could have a different scenario. You could have this side. Remember, two sides must be given. So you have this side and you could have this side. And if you're given side C and side A, then that means we're dealing with angle A and angle C. And of course, there's another situation that could happen. You could be given side A and side B. And then you're dealing with this angle over here and this angle over here. So for sine rule to work, in essence, there must be two sides and an angle facing those two sides. Of course, all will not be given because that's the whole idea of finding the missing one. So one will be missing. Whichever one will be missing, that's what we'll be able to find using sine rule. Of course, today we'll be dealing with the sides. Tomorrow we'll be dealing with the angle. Tomorrow, God's willing, that is, if we live to see, we will be dealing with finding an unknown angle. So for the sides, in essence, today we're focusing on finding either A, B, or C, meaning that the angles will be given. Notice here, if you haven't noticed as yet, sine rule, we don't use sine rule with a right angle triangle. So this is where the other triangles now come to play. Somebody was asking me sometime last week, okay, so I could use the trig ratios to find the angles in a right angle triangle and the sides. I say, yes, that's true. What if the triangle is not a right angle? How do I find a missing side? Well, here is a possible solution. If the triangle is not a right angle, meaning it doesn't have a right angle, a 90-degree angle, then sine rule and cosine rule are the way to go. And the formula here simply states that sine A over A is equal to sine B over B, which is equal to sine C over C. In other words, this basically tells us that every side and angle has it is approximate, not approximate. Every side and angle is a ratio of each other. In essence, that's what this formula is saying. But don't worry too much about the formula. The formula is very easy to pick up. It's one of the easiest formula I ever remember learning in maths, even before the Pythagoras theorem and even before the quadratic equation. I knew the sine rule. It was very easy. The minute I heard it, first day, I memorized it ever since. Notice here, just for notation, now you also be aware that the A here, the small a, is the side. So in other words, the denominator will always represent the side of the triangle. So you will notice that in all the formulas we do today, one bottom would be missing in one of the fractions that we will get. And sine A, this capital A here, is always the angle. Always the angle. You will want to remember that going forward. So let's do one for example. So again, like when we did trig ratios last week, we know that we know that we're using sine rule, so there's no if, but, or maybe. We don't have to figure that out, at least today. But in the future, you have to be able to identify. So again, notice, we are given two angles, and we know the sides facing them. Well, we don't know because this one is an unknown. but we could find out because only one is missing. And here I will start right away by getting rid of the notion of sine A over sine B and forget it. Let's just apply the sides with the concept that we know. So we know that 60 pertains to 12. So all we say here now is that sine 60 degrees divided by the side that is respective to that angle, which is 12, will be equal to sine 48 degrees over the side that is respective to that angle, which is t. This is all there is to it. So once you could figure out this, from here is just a matter of just simplifying or solving. In this case, we solve it because we want to know what is t. So to find t here, I will cross multiply and I will do 2 in 1. So I'll send up my t and I'll send down the sine 60 and then I send up the 12. Okay, well that sounds complicated. Let's do one step at a time. So cross multiplication, I end up with t over 12 is equal to sine 48 degrees divided by sine 60. So I'm just solving, or I'll find out what they are just now. And I want t to be the subject of the formula, so now I send up my 12. So that will be now t all alone is equal to sine 48 degrees multiplied by 12 all divided by sine 60. Good. And this is how we simplify. And from here, it's just a game of arithmetic. You just take a calculator and you find whatever value. Let me see if I could do that quickly. I'll round off in this case to 4 decimal places because I don't have space to put in anything else. So sine 48, according to my calculator, I'm getting 0. Let me put this in a different color. You will have space in your notebook, so you could go around. 0.7431. And sine 60 is supposed to be 0.5, right? Let me make sure. Is it? No, not sine 60, no. It's the other one, probably 30. Sine 60, I'm seeing here 0.8. I just mix up these and maybe cos. I think cos 60 is a half. Let me see. Cos 60. Yes, it's cos. Right. So 0.86660. And from here, I just multiply and solve. So let me multiply and see what I get. So 0.7431 multiplied by 12, I get that, and then I divide that by 0.8660. No. I make a mistake. Let me do that again. 0.71. No. Take your time. 0.7431. Yes. Multiply by 12. I get that. And then I divide what I just got there by 0.8660. Good. So I am getting, and I'm rounding enough to the nearest whole number. This answer looks possible. 10 centimeters. Is centimeters? What unit we working with? Yes, 10 centimeters. So this side here is approximately 10 cm. I round off to the nearest whole number again. Good. So that's what we get there. So that's basically how we use sine rule. It's not complicated so long as we understand what is happening. So this is an example. I think I have a few here for us to try. So here again, we know that we're dealing with the sine rule. So let's just state the formula. So notice this 30 here is corresponding to the 7 and this 55 is corresponding to the d. So we want to know what is d. So let's find out what is d. And again, in case you're wondering, it doesn't matter which one you put first, equal is equal. So if you put d over sine 55 over d, then sine 30 over, it doesn't matter. So let's put this sine 30 first. So there we have sine of 30 degrees divided by its corresponding side, which is 7 cm. So remember, the 30 is with the 7. And the angle always goes on top. The sine goes on top always. So sine 55 degrees divided by d. Good. And that is how we get our angle. Sorry, that is how we use our formula. This is the sine rule. And now we just simplify from here. So again, I'll do the same thing I did from the last one. So here D would be equal to, and I'm just doing everything in one lash, sine 55 multiplied by 7 all divided by sine 30. Yes, I just found D as a subject of the formula, and I just did a little algebraic manipulation. That's all there is to it. So 0 point, and again, to solve for D, this is where we just use our calculators. So just use the calculators, get sine of 55, multiply by 7, and then you divide that by sine 30. And I'm doing this quickly on mine. So sine 55 multiplied by 7 is equal to this, divided by sine 30, which I think is a half. Hold on, you're joking that. Alright, so sorry, let me say that. Sorry, something just happened. Sine 55 is equal to this, multiplied by 7. So at the top, I'm getting 5 point whatever. And then I divide that answer by sine 30. And my final answer is 11 point, well, no points. So I'm wrong enough to the nearest whole number. So let's say it's 11 cm. Is cm I'm working with here? Yes, cm. So this is my answer here. Again, based on the type of calculator that you have, be very careful. My scientific calculator could afford me to put all these values in one go and get an answer. But I know that there are scientific calculators, if you dare do that, you may not get the same answer. In fact, you might get something wrong. So you need to know your calculator so that when you're solving this type of questions, you will get the correct answer. If not, of course, just do like me, take your time, put sine 55, you put that first, then you whatever you get, you multiply by 7, and after you do that, you divide by sine of 30, right? If that will lead you towards the right answer, then fine. If not, yes, it's based on your calculator. Some calculators cannot input the values and give us the right output as we want to. But if yours can, go right ahead. And how do we know which one can? Just put something that you know the answer for and see what your calculator will produce. That's one of the easiest way to tell what type of calculator you're working with, right? Right. So let's try this one here now. I think this is the penultimate one. We have one more after this. So we have AT and E. So here we're finding E. I keep forgetting to read the question, but yes, we're finding E. And E is this side over here. So we have this side here corresponding with 30. 38 is corresponding with 10. And E is corresponding with 80. So let's start with the 80 in this one. It doesn't matter. So here we have sine 80 degrees divided by its corresponding side, which is E, is equal to sine of 38 degrees divided by its corresponding side, which is 10. And again, when I do my simi-dimi here and I make E the subject of the formula, I should end up with something like E is equal to, let us see, sine of 80, sine 80 multiplied by 10, or 80 degrees that is, all divided by sine 30. This is what we should get for 38 degrees. This is what we should get for when we make E the subject of the formula. And from here again, I'll go to my calculator and I type all this. I'll put it in one go because I know my calculator could handle that. So sine 30 multiplied by 10, all divided by sine 38. And according to my calculator, I am getting an approximate value of 16 meters. And this, of course, is rounded off to one decimal place. So E is 16 meters. Easy does it. And last example here, number 3. We have 70, 68. So this time we don't waste any time. Let's go. So we have sine of 65 degrees with its corresponding side, which will be this 9 over here, with over 9 cm is equal to sine of 70, jumping it on there, sine of 70 degrees divided by its corresponding side, which is k. We don't know this side, so this side is k. And again, when you're making KD sub-equal the formula, you should end up with something like sine 70 degrees multiplied by 9 all divided by sine 65. By the way, I did a video very earlier with the sub-equal formula. So if you're having problems to find the sub-equal formula, you might want to look at that video. I think it was very comprehensive, and hopefully after watching that, you should never have a problem again when it comes to finding the sub-equal formula. It's one of the things I love doing in maths. In fact, the higher you go in maths, you'll just get more complicated, but the basics, I could tell you, has never changed. So once you learn it well in high school, you would know it for life and for good too. Oh well, look at that. When I measured this, oh well, again, I rounded off. So in all fairness, it's not fair, but yes, I round off here to the nearest whole number. I actually got 9.33, so that will round down to 9. But I just said, look at this, 9 cm in 9 cm. So that would have made this an isosceles triangle. And if this was an isosceles triangle, that means that these two sides supposed to be the same because it's isosceles. But yes, as I said, I round off. So this side is not really 9, it's really 9.33, and it goes down the 9, 33152, whatever, right? So yeah, it's not really isosceles. And even though it is, again, it would have been a wild sketch because I just throw in numbers here. So I trust this helped a lot in understanding this sine rule. Tomorrow, God's willing, we're going to do the same thing, but we will be finding the angle, meaning that an angle will be missing and not a side. And that again just calls us to use the inverse of sine, or of course, arcsine. So that's the end of today's video. Again, as always, subscribe, share, like, comment, turn on that notification, and in the event that you haven't subscribed yet, that is, subscribe. If you have already, blessings. One love. Looking to reach 1,000 soonish, but there's no rush. Until then, you take care. Tomorrow, God's willing, when we look at the part 2 of this series.